property of log.
Welcome back. So exponential function f of x equals b to the x, where b is greater than 0 and b is not equal to 1. We know that b is, remember, the multiplier, or it is also called the base. So if we take graph f of x equals 2 of x, or 2 raised to the x, and graph f of x equals 1/2 to the x power. By plugging in -3, okay, remember the negative exponent tells you reciprocal, so we really have 2 to the third, which is 8, so 1 over 8. If we continue to do that, we'll get 1 over 4, 1 over 2, and then 2 to the 0 is 1, 2 to the first is 1, and so forth, all the way to 3 equals 8. By graphing it, remember the y-intercept is 0, 1, so we should get this graph. It goes from left to right, it increases by doubling. So if we look at this, what do we actually have? Our conclusion, okay, this is exponential growth where b is greater than 0. Our domain, what are all the x's that we can possibly plug in and get an answer? So if we look to the left, we can get all the way out to the very negative number, and we can go all the way to the right of the positive number and still get somewhere on the graph. So we know that it's the set of all x's such that we have all real numbers. The range. If we look at the y values, we know that this is going to increase 8 and so forth, so it's going to get really high. If we look at the other side, the negative part, it looks like it's becoming a fraction. So 1 over 16, 1 over 32, 1 over 64 is going to get increasingly smaller until it reaches a certain point. Now, will it ever be 0? No. So we know that it has to be greater than 0 for the y, so therefore y is greater than 0 for the range. Our y-intercept we already have is 0, 1. So based on the graph, we know that the graph is above the x-axis with the asymptote. We know the graph is an increasing graph, and it does have that horizontal asymptote at y equals 0, which is this dotted line in blue at y equals 0. Okay, on the right, if we have 1/2 x, well, notice the b is less than 0 right here, so 0 to 1, which tells us it should be an exponential decay. If we plug in the same numbers, this time we're taking the reciprocal of 1/2, which gives us 2, so 2 to the third is 8. So it's almost the same on the right, except for we're inverting, so -2 becomes 4, -1 becomes 2, and then now the 3 is 1/8. So this is decay. So again, if we look at the domain, notice all the way on the negative parts, you can still go up to the graph. It slightly, barely keeps going to the left, but grows up increasingly fast. So we can say that it's the set of all x's such that x is all real numbers. The range is, again, we have this horizontal asymptote at y equals 0. So again, we have y is greater than or equal to 0. We have the same y-intercept at 0, 1. The graph is still above the x-axis. It's not going to touch. The graph is a decreasing function. And like we said, the asymptote is y equals 0. Now we need to use our calculator. If we use our calculator to plug in the 3 functions, so f of x, g of x, and h of x, we get, with the y equals, there's our 3 functions. So the first one's going to get graphed is the 1.2x. The next one that gets graphed is 2x. And then the last one that gets graphed is the 3 to the x. Okay. There's our first one, that is our f of x. Now the next one that graphed is our g of x. And the next one that's graphed is our h of x. Notice the first one drawn out took a little bit longer to get up. Okay, the next one quickly started shooting up, and even the last one, the h of x, shot up quicker, which suggests there's our f, there's our g, and there's our h. Okay, so conclusion, the larger the base, the faster the growth. So now we need to describe the transformations based on f of x equals 2 to the x and graph it. What we can do is, let's just take the points that are given and we actually replug them back in. So if we start here at -1, okay, 3 times 2 to the -1 is going to give us 3 over 2. So this point right here on the far left is going to go up now. Instead of, looks like about a half, we're going to go up 1.5 and put a dot. If we do 0, we're going to go 3 times 2 to the 0, which gives us 3. So 1, 2, 3. If we take the 1 So 3 times 2 to the 1, you now get 3 times 2, which is 6. So this is going to shoot up to 6. If we do one more, which is 2, 3 times 2 squared, which is 3 times 4, which is 12. So the 2 becomes way up here to 12. So we get this blue increasing line here. Okay. If we actually look at this point that I just circled on the original function, that point, which is actually right there, okay, that did not shift anywhere. So it did not shift left, did not shift right, but it did go up. Okay, so we might think, well, it's a shift up. But if we look at the next point, which is now here, okay, if this first one went up 2, the next one actually went up 1, 2, 3, 4. So it's actually not the same shift. So this has to do with a stretch. So this is a vertical stretch by 3. Go ahead, hit pause, try B and C, check back with me in a second. Welcome back. If we look at B, or 2 to the x, and we've changed the x part from there. So if we look at our graph, and all I did was plug in the same point. So like I used -1 for x, 0, 1, and 2, and even 3, and then plot the points, and you get this function that's a little bit shifted. Well, it's not a stretch just like the last one, so there's nothing being multiplied in front of the 2. So it's either going to be an up shift, a down, or a left or right. Well, if we look at, if we remember the quadratics, if the x part changes, usually it is a shift left and right. So if we plug in and we'll look at that x minus 3, what makes that 0? And if you notice, it's 3. So this is going to tell us that it's going to shift 3 units to the right. So it's a horizontal shift, right 3. And if you look at C, the 2 of x, which I'm circling right now, and this are completely the same. So there isn't going to be any vertical shift or compression. There isn't going to be any horizontal shift left or right, but we are adding 3. So if you notice, they take this 0, 1, and all of a sudden it shifted up 1, 2, 3 to here. Well, if we look at these subsequently the same points, if we look at these points that mirror the other image, what we'll see is this whole graph, the original function, shifted up 3. And now the asymptote is now at y equals 3. So if we were to plug in 3 for the g, 2 to the x plus 3, and solve 2 to the x equals 0, there is nothing that we can plug in for x to make it equal to 0. So therefore, that's our limit line, and everything else is above 3 now. Last two, the parent function for each graph is y equals a b to the x. If we want to write the parent function, then write the function for the translation indicated. We have a graph. We need to write our graph in a, b, x. So y equals a, b to the x. And then use this translation, left 3 and up 1, to write a new function. First thing what we want to do is try and hopefully find 2 points. So, and if you can, we want the y-intercept. So we have 0, 1, and then we have 1, 2. Okay, we're going to use those 2 points. So plug in the y-intercept first. So we have 1 for y, a, b to the 0. B to the 0 is 1, so we know that a equals 1. Now replug back into the equation. Now we have y equals 1 b to the x. And now the only last thing that we need is we need to find the b, or the multiplier. So we're going to take this second point and we're going to plug it in to the equation again. We're going to get, we have 2 for y, we have 1, we have b to the first. 1 times b to the first is b, so b equals 2. So our original function is y equals 1, 2 to the x. Okay, so that's the original function. Now we're going to write the translation. Well, if we know it's up, we know we have to add 1 on the outside. If it's shifting left or right, well, left is negative, so think opposite of negative is positive. So that's going to change the x part. So we're going to go x plus 3. There's our function. Go ahead, hit pause. Try number 2. Check back with me in a couple minutes. Welcome back. If you notice, all I did was stop at the original function. So the function we get by using 0, -4 and 1, -2. We get a equals -4 and b equals 1/2. Plug it in and we get y equals -4 times 1/2 to the x power. There's our function. Now we need to translate the function into what they gave us, right 3 units and up 1. So we get y equals -4. We don't change the base or that stretched unit. It is shifted to the right. So right number is positive. So think opposite is negative. So we're going to change this to x minus 3 this time. And then add 1 because it shifted up. Congratulations. There's our new function.
And remember, do the best, forget your S. Meow!
Bye for now.